Hook, what if the security that protects your Linux server could be nudged open by an overconfident, unprivileged user? Today we're diving into CrackArmor, 9 hidden flaws in AppArmor that threaten root access and container isolation. Yes, 9. And yes, they've been lurking since 2017. Context setup: AppArmor is Linux's built-in mandatory access control system. It's supposed to keep apps from misbehaving, even if they get into trouble. But according to Qualys TRU, a set of confusing deputy flaws lets unprivileged users manipulate AppArmor profiles, bypass user namespaces, and escalate to full root, all while jeopardizing container security. This isn't just a nerdy kernel detail, it touches millions of enterprise endpoints that rely on AppArmor by default. Main breakdown: Idea 1. The confused deputy flaw concept. Explanation: a privileged tool gets tricked into misusing its own privileges by an unprivileged actor. In practice, that means an attacker uses a trusted process as a weapon, not by breaking the tool, but by bending it to do something it wasn't meant to do. Commentary: personally, I think this reframes security as a ballet of trust. It's not about breaking the lock, it's about convincing the keeper to open the door. What makes this really interesting is that the attack emerges from the very patterns we rely on: legitimate tool behavior, complex policy parsing, and namespace interactions. If you take a step back and think about it, the root vulnerability isn't just code, it's a design. Who's allowed to tell the truth to the kernel, and under what contexts? Analysis: the implication is that even trusted components can be misled when the surrounding policy or tooling has subtle gaps. This raises a deeper question: how do we prove that a tool's trusted state remains pristine under all orchestrations, especially under multi-tenant or containerized workloads? Perspective: this isn't a one-off bug, it's a systemic cautionary tale about layered security. It points to a need for simpler, more verifiable policy processing and stronger isolation guarantees at the kernel boundary, independent of user-land tools. Main breakdown: Idea 2. How CrackArmor bypasses user namespaces and profile parsing. Explanation: the flaws enable bypassing user namespace restrictions and manipulating AppArmor profiles to disable protections or enforce overly permissive policies. Commentary: what many people don't realize is how user namespaces were intended to reduce privilege by mapping user IDs. CrackArmor flips that script, letting an unprivileged actor weaponize the very mechanism designed to separate tenants. From my perspective, that's a reminder that namespace boundaries are only as strong as the policies that gate them. Analysis: if an attacker can coax AppArmor into misapplying its own rules, they can create a full path to arbitrary code execution in the kernel. That also means denial of service via stack exhaustion and potential leakage of memory layouts, KSLR bypass. It's like pulling threads in a sweater until the whole fabric unravels. Perspective: this signals a broader trend: container security is only as strong as its weakest link in the policy chain. When policy engines and namespace boundaries interact in delicate ways, a small misstep can cascade into widespread compromise. Main breakdown: Idea 3. The risk scale across Linux distributions and kernels. Explanation: the advisory claims the issue affects all kernels since 4.11 on any distro that uses AppArmor by default, including Ubuntu, Debian, and SUSE. Commentary: personally, I'd frame this as a systems-wide wake-up call. With millions of enterprise instances exposed, the attack surface isn't a niche lab scenario anymore. What makes this really interesting is watching large organizations scramble to patch across diverse environments and versions. Analysis: the lack of CVE identifiers at the moment doesn't mean quiet risk, it means patch coordination is muddled. The pace of kernel fixes has to outstrip the attacker's ability to weaponize unpatched systems. This underscores why zero-day style urgency is not a slogan but a real pressure situation for security teams. Perspective: it highlights a trend: the speed at which we patch must match the speed at which threats evolve, particularly for security modules that sit between apps and the kernel. The vulnerability lifecycle matters as much as the vulnerability itself. Main breakdown: Idea 4. immediate mitigations and the POC withholding. Explanation. Qualys is delaying POC exploits to give defenders time to patch, emphasizing kernel patching as the non-negotiable priority. Commentary. From my view, that's a mature, responsible stance. It buys defenders time to implement fixes before attackers get a blueprint. What makes this interesting is how it frames defense as an active game of cat and mouse. Coordinated disclosure can be a feature, not a delay. If you're a sysadmin, this is exactly the moment to sanity check patch catalogs and test environments. Analysis. Interim mitigations won't offer the same level of assurance as a vendor-fixed code path. This is a reminder that in security, you don't chase perfect patches, you chase timely, verifiable fixes and compensating controls until the official patch lands. Perspective. The episode reinforces a broader shift toward proactive patching culture, especially for kernel-level security modules where misconfigurations compound risk across all workloads. Deeper insight. What this implies for the future of Linux security. Commentary. What this really suggests is a need to re-examine trust boundaries at the kernel module interface. If AppArmor can be manipulated by unprivileged actors, maybe we need stronger, formal verification of policy parsers and more robust isolation guarantees inside containers. What makes this compelling? It demonstrates how modern security is a system of systems, policy engines, namespaces, kernel code paths, and tooling all interacting in unpredictable ways. A single design assumption can ripple outward into massive risk if not rigorously validated. Interpretation. I'd speculate that similar class vulnerabilities could exist in other Mac/IBC modules that sit at the border of userland and kernel space. The industry needs more automated, end-to-end testing that simulates real-world multi-tenant workloads to catch these misalignments early. Reflection. In practice, this elevates the role of patch management maturity. It's not enough to install updates, you need to validate policy integrity, recheck containers, and audit how your security tooling interacts with the kernel under varied workloads. Closing thought, open question for the audience. Takeaway. The CrackArmor case is less about a single bug and more about how we design and maintain layered security in a world of universal virtualization and containers. Open question. If you're responsible for a fleet of Linux hosts, what's your plan to ensure your AppArmor policies remain resilient during patch cycles? Do you have automated tests that simulate common attack patterns against your own profiles? Final note, stay tuned for patch availability, and I'll walk through how to validate updates, recheck your policies, and test container isolation after you pull the fixes. If you want more depth on any specific angle, policy parsing, namespace interactions, or practical hardening steps, drop a comment and tell me what you'd like to see next. Also, I've got a quick checklist you can use this week to audit your AppArmor setup and plan a safe patch rollout. Would you like that?